In this video, we're going to talk about differentiation of a vector. How to differentiate a vector. All right. If a vector A and is equal to AXI plus AYJ, all right, plus AZK. If this vector depends on a scalar variable u, for example, let's say u, that is A of u equal to A sub x of ui plus A sub y of uj plus A sub z of uk. That means u is the independent variable, all right? We can differentiate the vector A with respect to u. The A of u du, that is, I'm differentiating this now with respect to u, is equal to I, let me write I first, dA sub x of u du, okay, plus j dA sub y of u du, plus k dA sub z of u du. I am differentiating each of them with respect to u because the vector depends on a scalar quantity u. So this is how to differentiate a vector. The question says that if A equal to I into u squared plus 5 minus j into u squared plus 3 plus 2u cubed into k. We are to determine dA du, d squared A du squared, and the modulus of dA du, all at u equal to 2. All right, let's proceed. What is dA du? Okay, we are going to differentiate each of them here. All right, so dA du is equal to, we are going to differentiate this now. That's I d du of u squared plus 5 minus j d du of u squared plus 3 plus k d du of 2u cubed. Okay, so what we have now is this. I into differentiate u squared plus 5 with respect to u. We are going to obtain 2u plus 0. That's the rule of differentiation. Differentiate u squared with respect to u. We are going to obtain 2u. All right. The rule of differentiation is this. If y is equal to ax to the n, dy dx, all right, is equal to n times a, that's an times x to the power of n minus 1. Multiply the power by the function, then subtract 1 from the result. So 2 times 1 is 2, subtract 1 from the 2 to get 1. 5 is a constant, and the derivative of a constant with respect to any variable is 0. Minus j into differentiate u squared, we are still going to obtain what? 2u. Differentiate 3 with respect to u, that will be 0. So we have 2u plus k into differentiate 2u cubed with respect to u, we are going to obtain 6u squared because 3 times 2 is 6, 3 minus 1 is 2. So this is dA du. At u equal to 2, dA du is this. Plug in 2 for u here. 2 times 2, that's 4. So we have 4i. 2 times 2 is 4 again. Times minus j, minus 4j. Okay, put 2 here, that will be 2 squared, 4. 4 times 6, 24. Times k, 24k. So this is dA du at u equal to 2. So let us determine d squared a du squared. So to get a second derivative, we're going to differentiate this one. All right. So d squared a du squared is this. We have to differentiate this now. All right. So let's differentiate. Differentiate 2u with respect to u. That will be 2. So we have 2i. Differentiate 2u again with respect to u. We have 2. So 2 times minus j, that's minus 2j. Differentiate 6u squared with respect to u. We have 12u, because 2 times 6 is 12. 2 minus 1 is 1. So that will be 12u times k. 12uk. At u equal to 2, d squared a du squared, which is this, will be equal to, we'll plug in 2 here, that's 2i, there's no u here, so we have 2i minus 2j. In place of u here, we write 2. 2 times 12, that's 24k. So this is d squared a du squared at u equal to 2. Now, let us determine the absolute value of the a du at u equal to 2. We can either choose to take the modulus of this, right? That's the a du, that's this, and then evaluate it at u equal to 2. Or we just go straight to take the modulus of this one already, since this one gives us the a du at u equal to 2. But I'm going here straight, okay? I want to evaluate this. So, the absolute value of the a du at u equal to 2, I'm taking this vector now. Remember the formula for the magnitude of a vector that says the magnitude of a vector is equal to the positive square root of ax squared plus ay squared plus az squared. So this is ax, this is ay, this is az. So we have the a du equal to the square root of 4 squared plus minus 4 squared plus 24 squared. And what would this be? 4 squared is 16, minus 4 all squared is still 16, 24 squared is 576. So if we evaluate the square root, we have to 2 decimal places 24.66. So 2 decimal places. So this gives us the absolute value of the a du at u equal to 2. Keep supporting by subscribing to this channel, like and share the video to your friends and to your classmates. I'll see you in the next one.